Hello everyone. Again, I'm going to demonstrate the Vandegraph machine, which is this device right here. I'm going to show you the principles of conduction, scraping, and induction for charging objects. As just a reminder from last time, the only way that you can charge objects is by transferring electrons, and the three ways that you can transfer electrons is by scraping, by rubbing the balloon on my hair. I can remove electrons from my hair, and depositing them on the balloon makes the balloon have a negative charge due to the excess electrons, and the deficit of electrons in my hair leaves my hair with a positive charge, and then there's an electric force between those opposite charges attracting the balloon to my hair. Conduction is if I take a charged object and touch it to another object, the electrons can transfer to the other object. Okay, so after I charge up the balloon, if I rub my hand on the balloon and then touch my hair, then the electrons are removed from the balloon and deposited back on my hair. Okay, leaving the balloon and my hair electrically neutral. So that's a process of conduction. And then induction was when I rubbed my hair on the balloon, and if I went to stick the balloon onto the ceiling, the negative charge on the balloon would repel the electrons on the surface of the wall, leaving the surface of the wall positively charged, and then those opposite charges are attractive, holding the balloon on the ceiling. And then of course the electrons on the balloon are slowly conducting into the neutral ceiling, so eventually the balloon will lose its charge and will fall back onto the ground. Okay, so this is the Vandegraph machine, and let me show you how this works. This is just a metal dome that sits on the top, and here's another metal housing that sits around the bottom part. And if you look at this machine up close, there's a rubber band inside right here. This is a rubber band right here that rotates, okay? And it rotates on this plastic pulley, okay? And then the upper part here has a metal pulley that the rubber band rotates on. So this rubber band is basically going round and round inside of this tube, okay? So what happens is that the rubber band acts like my hair, and this plastic pulley right here acts like the balloon, and the electrons are being pulled off of the rubber band into the plastic tube and going into the reservoir here, and these leaving the rubber band with a net positive charge. Okay, and then that positive charge is carried by the rubber band up to the top right here. And this metal screen right here has little spikes on it that collect the electrons, collect that positive charge, and it's deposited on the upper dome. So essentially, the bottom spike, right, the pulley on the bottom right here removes electrons from the rubber band, leaving the rubber band with a net positive charge that is carried up to the top here. Okay, and then electrons in this upper dome are basically pulled towards that positive charge through the screen right here, leaving a net positive charge on this dome. Then some of the positive charge stays on this rubber band as it goes back down, and in order to keep the rubber band from being overcharged, so you can keep on picking off electrons on it, this screen down here deposits electrons back onto the rubber band, keeping it electrically neutral as it goes back around this pulley again. And then this pulley goes around again, removes the electrons, and the positive charge is deposited back on the top again. Okay, and the reason that you have to do that is because if this is positively charged, eventually that little plastic cylinder will no longer remove electrons anymore, and you're limited to how much charge you can get off of it. So this keeps putting electrons back on it, so you can just keep removing charge and then keep depositing it up here. Okay, so let me, and I'll just turn this on so you can see it all rotating. Okay, so you can see that thing is spinning right now. Okay, and essentially electrons are being removed from the bottom pulley and being deposited up here. And the positive charge is being deposited up here. And then the metal screen right here is putting electrons back on the rubber band, making it neutral before it goes back into that pulley again. Okay, so now I'm going to cover this back up. Okay, so the bottom housing here is a metal housing that's connected to the bottom screen, which will become negatively charged. Okay, and then the top one here is going to become positively charged. Okay, so let's just see if it works now. Okay, so I'm going to turn this on, let it charge for a minute, and if I connect the top to the bottom right here with this wire, you should, they would have the electric charge from the bottom dome is going to be repelled into this wire. So the electrons from that negatively charged dome are going to be repelled to the end of this wire. You turn the light off, and if I move this close to the dome, you can see some sparks. Okay, can you see the sparks? Okay, you can see some sparks flying across right there. Those are the electrons coming from the bottom conductor to the upper dome. The dome is positively charged, so it's pulling electrons off of the wire into the dome. Okay, can you see those? Okay, so, okay, and you can see that when I walk by this thing, I can feel the electric field pulling on my hairs. Okay. All right. So now I have this is what's left of my neighbor's cat. So I'm going to put this on top right here. Okay. So I put that on top, and you can see that he's coming back to life. You can see that the fur is rising up. Okay, because what's happening now is the positive charge that's on the dome is inducing, pulling the electrons toward the dome, making the ends of all the hairs, the ends of all the hairs are positively charged now, and positive charge is repulsive. So all of these hairs are trying to move as far apart from each other as they can. Okay, and you can see if I move this wire next to it, okay, this wire has the charge of the bottom dome. You can see that I can remove this charge by just touching this wire to the hairs. Okay? Okay? So now it's going to charge back up again. Alright? And then if I put this wire next to it, it removes the charge from the hair and leaves it neutral again. Every time I touch this thing to it, it neutralizes the charge. Alright? Now I'm going to let it charge up again. And now I'm going to take a piece of string. Okay? Well, we know that the ends of those hairs are all positively charged. So the string, if I move it close to this, that electric charge will induce a charge in this string now. Okay? So that electric charge that positive charge will attract electrons in the string towards the end, and you'll end up with a force of attraction, like Coulomb's law. So you can see that the string is electrically attracted to this. Okay, so that means that the ends of the string must have opposite charge of the cat fur. right? See, over here, the string would be electrically neutral now, and it's not doing anything, right? Just gravity pulling it down, and as I move the string closer, the electric charge from this induces a charge in the string, and that negative charge in the end of the string is attracted towards the positive charge on the cat fur, okay? Okay, so this is an example of induction, okay? And you can see here that when I neutralize this, when I neutralize the cat fur with this wire, I'm basically taking these two oppositely charged objects and neutralizing the charge here through the wire. That's called conduction. So as soon as I touch this wire to the cat fur, the charge neutralizes, and the charge is transferred from the bottom to the top, neutralizing it. Namely, electrons are being transferred through the wire to the dome on the top, neutralizing it. So let's let it charge up again, and I'm going to remove the cat fur. Okay? And now I'm going to take the string again, and I'm going to touch the dome with it. Since the dome is positively charged, okay? Since the dome is positively charged, if I touch the string to the dome, now by conduction, the string should be positively charged now. And as the positive charge is transferred to the string, you can see that the string is repulsive. The end of the string is becoming repulsive to the dome. Okay, so the string is pushing out that way towards the out into space. Okay, and the string is, every time it touches it, it just becomes positively charged, and the two positive charges repel each other. Okay? So the reason it's touching to the top up here is because the part that's touching it, it's inducing a charge here, and so this part of the string is negative. Okay, so that's why it's not being repelled from the top. Okay, but the end is got a positive charge on it. The end of the string has a positive charge on it, and it's being repelled. Okay.
But it sticks to the bottom one.
Well, yeah, it sticks to the bottom one because that one's negative. Okay. It's attracted to the bottom one because the bottom one is negative. So I charge the string up positive by touching it here, and then now, okay, by touching the string here, it induces a charge in the wrist, making this positive, and the bottom one is negative, so it pulls it towards it. Okay, so that's just another example of induction, and as you can hear, it's sparking to the air. You might even be able to see it if we turn this light up. Let's see if we can see it sparking into the air. So that sparking is it's becoming charged up, and it's actually discharging to the air. So if I can discharge it right here with this wire right here. You can see the sparks coming off of the wire. Okay, so let's here's another experiment that I like to do sometimes is deflecting this water beam. Okay, there's some water dribbling out of my faucet, and it's hitting the center of the sink right here. Okay, and as you know, water molecules are have an electron cloud around them. And if I take this wire and move the wire close to this water beam, you can see that it is deflected towards the left. And I'm not touching that water beam. And sometimes if I use this ruler to do it with, I can get closer with it, like putting my ruler on here. Okay? So if I hold this onto the dome, it's got a positive charge on it. And if I move this close, you can see that the water beam is being deflected to the left. And I'm not touching it. I'm not touching the water beam. Okay? I did touch at that point, but to wipe it off.
Try it again.
So you can see the water beam is just falling straight down due to gravity. And if I move this close to it, it's deflected. I can't see through that camera there. Let me go here. So when I move this this close to it, it's deflected to the left. Okay?
Looks like you're touching it.
Nope, I'm not touching it. It's dry. Okay? Try it again.
You come to the other side.
Yeah. Okay? Okay, you ready? We'll do it one more time. I'm touching the top dome here with the wire, and the other end of the wire is on the end of my ruler. So as I move this ruler close to this, it pulls the water off to the side.